Picture this. You bring home a new smart bulb, power it up, and your phone suddenly sees a Wi-Fi hotspot called Smart Bulb _setup. That's access point mode. Once you configure it with your home router's details, the bulb switches into station mode and starts talking to the internet. This simple dance between two Wi-Fi modes is at the heart of most IoT products, and the ESP32 gives you full control of both. In this lesson, you'll learn exactly how station and access point modes work, why each one matters, and how to use them in your projects to build devices that are flexible, configurable, and reliable from the start. Think of station mode as your ESP32 behaving like a laptop. It scans for nearby Wi-Fi networks, authenticates with a router, and once connected, gets an IP address via DHCP. From there, it can push sensor data to the cloud, request APIs, or even serve web pages inside the LAN. In my projects, station mode is the default because it keeps devices integrated into the customer's network. But here's a question to think about. What happens if the router credentials change? That's why many engineers build a fallback to access point mode, ensuring devices never get orphaned and locked out of updates or remote control. Access point mode flips the role entirely. Here, the ESP32 is the router. It broadcasts its own SSID, manages IP addresses for connected devices, and becomes the local hub. I use this mode often during setup phases, when the end user first installs a device and needs to provide Wi-Fi credentials. It's also useful in places without internet, like farms or warehouse, where local control is enough. The trade-off is range and performance. The ESP32 isn't designed to replace a high-power router, but for short-range direct communication, it's a reliable and flexible tool. One of the most underrated features of the ESP32 is its ability to run as both station and access point at the same time. This is gold in real-world deployments. For example, I once built an industrial sensor system where the ESP32 streamed data to the cloud over STA while still allowing technicians to connect locally through AP to view diagnostics. It's like having two doors, one for public internet traffic and one private entrance for maintenance. Just remember that running dual mode increases radio activity, which means more power usage and potential channel overlap, so use it wisely. Here's a simple sketch to get your ESP32 onto your home Wi-Fi in station mode. The key lines are Wi-Fi.begin, SSID, password, to start the connection, and Wi-Fi.local IP, to check the assigned address. In real projects, I always add retry logic with a timeout, otherwise, your code might hang if the router is unreachable. Once connected, that IP address is your gateway to serving web pages, sending MQTT messages, or pulling data from APIs. Always log it to serial. It'll save you countless debugging hours when troubleshooting network issues. Now let's look at AP mode. Using Wi-Fi.softAP, SSID, password, your ESP32 instantly becomes a hotspot. The Wi-Fi.softAP IP command gives you the app's IP, usually 192.168.4.1. Connect your phone or laptop, and you'll see the ESP32's SSID show up like any other Wi-Fi network. This mode is perfect for setup portals. I once built a smart irrigation system where farmers used AP mode to configure watering schedules directly on the field without needing internet. Just remember to use a password. Open networks may seem convenient, but there is security risk. Here's where most people trip up. First, hard-coding Wi-Fi credentials without fallback leads to brick devices when SSIDs change. Always provide AP fallback. Second, don't leave AP mode open. I've seen test devices hijacked because someone left the password empty. Third, remember that Wi-Fi is noisy. Multiple ESP32s in AP mode on the same channel will interfere. And finally, battery-powered devices struggle with constant Wi-Fi. If you need both AP and STA, plan sleep cycles carefully, or you'll drain batteries fast. These are lessons that only show up in the field, but knowing them upfront saves costly mistakes later. The best way to master these modes is to build small, targeted projects. Try creating a captive portal in AP mode where users input Wi-Fi credentials, This is how most commercial devices handle first-time setup. Or run dual AP plus STA and serve a debug page locally while pushing sensor data to a cloud MQTT broker. Even something as simple as scanning Wi-Fi and printing signal strength across your house will show you how physical environments impact performance. These experiments may look small, but they'll train you in the exact skills professional IoT engineers rely on daily. So now you've seen both sides of ESP32 networking: station mode to join existing routers and access point mode to host your own. You've also learned how combined AP plus STA mode keeps devices connected while still offering local access. These aren't abstract features, they're the backbone of real IoT deployment. Every commercial product you've used, from smart plugs to industrial sensors, uses the same principles. As you move forward, think carefully about which mode fits your project's context, how you'll recover from failures, and how to balance usability with security and power constraints.